1 times 36 x to the 4th, y to the 10th, z to the 5th. This one's going to be positive 4 over, that's going to be a 9. And that's going to be an x to the 10th down here. That's going to be a y to the 14th up there and a z to the 6th up there. This, as you can see, they're all very similar. But take a look at the answers. Negative 10 over x to the 3rd. That's already starting to look forward. Negative 10 over x to the 3rd. Negative 10 over x to the 4th. Negative 1 over 1,000 x to the 3rd. And this is positive 1 over 10,000 x to the 4th. Yeah, right from the side like this. So there, that is 5 to the x. And this one equals 5 to the 42 happy face. So let's start with 1 and or 2. You didn't get an assignment sheet or the rules of exponents. Have a few left over, we'll see. Assignment sheet. It's also posted, rules of exponents and the exponent chart also posted. Question 1 or 2? Both. So that number 1 is a short form of the quiz prep that I posted. Question number 3. Question number 3 over here. So instead of x to the 4th, I put a 4z to the 3rd. And then I didn't write as many parentheses straight across. I gave you one more parentheses, I put a 3 inside with the x squared. I added an extra variable and then I squared. So I gave you one outside term times 1 parentheses for the second. On the quiz prep, it was this one, a couple of parentheses times that one. 1 4 z to the third times 3 x squared y to the fifth z the whole thing is squared. So remember what I was telling you last week. You can watch me do these all day long, but if you don't try them for yourself, coming in Wednesday for your quiz, you're not going to be ready. And if you're struggling doing these on your own, then there's tutoring available in the tutorial lab. The schedule is posted on Canvas. There's office hours. Okay. Before class on Wednesday, and then on Tuesday, Thursdays at 9 o'clock in here. So, and then you have obviously you have the correct before the quiz on Wednesday. But you have to be able to practice this on your own. Quizzes are open, no, tests are not. So you can have an example like this for your quiz, and all you have to do is be able to transfer this knowledge, this example, into the problem that you're at. You're not going to have 10 questions. Some of you will feel like it's 10. But in like one problem, you have like 10 things to do. And you got to take care of each individual piece one at a time. There's nothing we can do out here. There's a parenthesis. There's nothing you can do in here, but that parenthesis to a power. I need to simplify this exponent before I can do anything with this. Before I multiply, I got to do that power. In that power, it's this rule of exponents. Anytime you have a product, this is rule number 3, the power, each factor gets raised to that power. So everything in here is going to get raised to the second. So we have 4z to the third times everything's going to get raised to the second. So 3 is going to get raised to the second. Now, I'm going to go ahead and just advance to a step and not write everything out. Because you also cannot spend time writing every little step out. You should be able to go to this step. 3 is going to get squared. 3 squared, that's going to be a 9. X squared is going to get squared. Y to the fifth is going to get squared. Z is going to get squared. And when you square these, it's going to be power to a power. That's rule of exponent number 2. A to the m raised to the nth power. Power to a power, you multiply the exponents. So when I square x squared, 2 times 2, that's going to give me x to the 4th. Y to the 5th squared, 5 times 2, that's going to be a y to the 10th. And that's z to the 1st squared. So z to the 1st squared, 1 times 2, that's z to the 2nd. You should be able to take that step. You should be. And if you're not comfortable with that step, then in between you have the z, or z to the 3rd. And then inside the 3 gets squared. The x squared is going to get squared. The y to the 5th is going to get squared. And then you got to square the z. And then right below that is what happens after all those things. So you either can write that step down, or you take that next step. You take that without writing it down. You know what bugs me? Is those people who show up and can take 2 steps and then walk up a set of stairs at a time. My knees can't do that. Oh, but they're so, like, look at them burning those extra calories. They're taking 2 steps at a time. My brother-in-law used to be able to do that. Another one passed away. Another one passed away 2 weeks ago. They're all like in their 70s. I'm in my 50s. We're in the next 3. 2 more years. after the next couple of months, 58. When I was a little kid, there goes my brother when I was like taking 2 steps at a time, I'm just falling behind. Watching, I kid when you can't take 2 steps here. Any questions? Now it's just multiplication. The coefficients 4 times the 9. It's not distribution where you just like wrote, distribute it all in. You're only going to multiply the coefficient times the coefficient. 4 times 9 gives you 36. And then there's no x's, so I'm left with an x to the 4th. There's no y's out here, so there's just a y to the 10th. And we have a z to the 3rd times a z to the 2nd. That's rule number 1. I'm going to have to make some room there. A to the m times a to the n. You add the exponents. It is a to the m plus n. So 3 plus 2 is z to the 5th. Well, what actually happened? And again, so you understand what's really happening. Simplify the parentheses. That's what we did from the blue to the red to here. The parentheses, we can't do anything, so we can drop the parentheses. This is all multiplication. This is 4 times z to the 3rd times 9 times x to the 4th times y to the 10th times z to the 2nd. All multiplied together. There's a rule in math called the commutative property. We don't make a move in mathematics unless we have a reason that says it's okay to do. Everything we do in math is either proven true or accepted as true. There's 2 commutative properties. There's one for addition. If I add A plus B together, I get the same answer as if I did B plus A. It doesn't matter what order you add things in, you still get the same answer. 5 plus 2 is the same as 2 plus 5. So it's okay to switch which one you put first. The same thing with multiplication. A times B is the same as B times A. 3 times 7 is the same as 7 times 3. It doesn't work with subtraction. So it's no one. 8 minus 2 is not the same as 2 minus 8. I cannot switch the order for subtraction. Same thing with division. 9 divided by 3 is not the same as 3 divided by 9. It only works with addition and multiplication. So all that's saying is I can switch positions. I can trade places. 4 times 9 times z to the 3rd times x to the 4th times y to the 10th times z to the 2nd. And then I can keep trading places, kind of move this one and exchange it with the x, and then exchange the z with the y until I have 4 times 9 times x to the 4th times y to the 10th, z to the 3rd times z to the 2nd. Then I can multiply 36, x to the 4th, y to the 10th, z to the 5th. When you become a math major in college, we do problems that are proofs of things like this, that are anywhere from 130 to 180 steps, taking every little increment and giving the reason why it's okay to do. Because every little step has a reason why. Nothing is taken for granted. Because that's what's important. It's all in the details. All you need to be able to do is go from here to there, and from there to there. You do steps. Okay. I don't want you to feel overwhelmed by all this stuff in between. You're not trying to eat a quadruple stuffed Oreo that just makes you sick. And then number two, important part about number two is order of operations. And that first step of simplify inside the parentheses first. Anything we can simplify in the parentheses is just going to make our life easier before we do the square. Parentheses and then that exponent. Parentheses and the exponent. So in the parentheses, it's a negative. And you have a common factor for an 8 and a 12, which is a 4. So I see negative 4 times 2 over, this is 4 times 3. And if you just want to go, okay, 4 goes into this 2 times, 4 goes into that 3 times, I'm fine with that. Negative exponents mean reciprocal. So rule number 8 down here, a to the negative m, if it's negative in the numerator, it flips down, you get a to the positive m, or if it's negative in the denominator, you flip it up and it becomes a positive exponent in the numerator. So since this is a negative 5, that's going to flip down. I get x to the positive 5. Y to the 4th is a positive exponent, so it's going to stay put. This y to the negative 3, it's a negative exponent, so it's going to flip up. That's now a y to the positive 3. That's a z to a positive 3, so it's going to stay put. Leave it up there, z to the positive 3. You want all the exponents to be positives, and this whole thing is still to the second. We still got to clean that up. So 4 reduce, and we have parentheses still, 2 over 3, negative. Y to the 4th times y to the 3rd. You add the powers, 4 plus 3, that's y to the 7th. That's the only z. There's no z's down here to simplify with it, so that's z to the 3rd. And down below you have an x to the 5th. And the whole thing is still squared. A lot of the times when you're working a question like this, if you're not neat about it, you forget there's a 2 here. So you move on to the step and you don't have the 2. So you've left off that last piece to do. So now you're just going to square everything inside. It's a negative in a parentheses and you're going to square it. So it comes out what? A sign, positive or negative? Positive. I have a negative in the parentheses, so a negative squared is going to equal a positive. Now I don't have to worry about the sign, because it's in the parentheses raised to an even number. A negative in the parentheses to an even equals a positive. If it's a negative in a parentheses to an odd, that's a negative. Now this 2 squared is 4. Down below, 3 squared is 9. So we're squaring everything. 2 squared, 4, 3 squared, 9. Y to the 7th squared. So when I square it, just like I did here, x squared to the second, we multiply the exponents. 2 times 2 gave me x to the fourth. That x squared got squared. So y to the 7th squared is y to the 14th. Z to the 3rd squared, multiply. 3 times 2, that's z to the 6th. In the denominator, x to the 5th squared, 5 times 2, that's x to the 10th. Nothing else reduces. But because I simplified the fraction, the 8/12 before I started, I don't have to worry about reducing 4/9. That's going to be in lowest terms. Reduce the fraction if it does reduce before you square it out, cube it out, whatever it is. It will already be in lowest terms if you've done it first. Any clarification on that? Uh, 3 through 6. Anything there? 5 and 6. Okay. You know what? I think it actually kind of will work best if I actually compare all of 3 through 6. Because they all have something in common and not in common. So let's just line them up. Number 3, -10, x to a -3, 4, -10, x to the -4. If you have a negative to an even, but it's, well, and it's in parentheses, that's going to be a positive. If you have a negative to an odd in parentheses, that's going to be a negative. Question is there a parentheses when you raise it to an even power? Right. First of all, here, the only thing being raised to either of these exponents is the x. The -10 is not being raised to anything. So the only thing being affected by that exponent is x. So since x has a -3, we're going to flip that down. -10 stays put. Flipping down is now x to a +3. And that's all that's going to happen. Nothing can reduce. There's no parentheses around a 10 at all. If you had 10 times x squared, that squared does not apply to the 10 whatsoever, because only x is being squared. Now, if there was parentheses around it, then you would square the 10, and this would be 100 x to the second. But if there's no parentheses, now only x is being squared, not the 10. So is there parentheses, is there not parentheses? What's the base? And if there's ever any question, come on up and ask. Same thing here. The only thing that has an exponent is x. So negative 10 is going to stay put. This is going to flip down, become x to the positive 4. And this negative 3 is supposed to be out here. I can do 5 one of 2 different ways. So let's do it the first way. Rule number 3. Product to a power, each one gets that exponent. So negative 10 is going to get raised to the negative 3. Negative 10 is going to get raised to a negative 3. And the x is going to get until negative 3. Now, how do I raise negative 10 times itself negative 3 times? No, nobody can. You make it a positive exponent. That's why the directions is going to say positive exponents only. So that'll help you remember, hopefully, that you're going to flip it. And if you're going to flip it down and there's nothing in the numerator, then you need to put a 1. Because the rule says, if you just have a to the negative m, it flips down to the denominator, reciprocal. It has to be under something. Well, it would be under a 1. So it's 1 over, this is now parentheses negative 10 to a positive 3. X to the negative 3 would also flip down and be x to a positive 3. This is a negative to an odd power. So it's going to equal a negative down here. 10 to the third would be a 1 with 3 zeros. 10 times 10 times 10. That's 100 times 10. And 100, 10 $100 bills is $1,000. So negative 1,000 x to the third. And as long as you have one negative, the whole thing's negative. So it doesn't matter if you put 1 over negative 1,000 x to the third, negative 1 over 1,000 x to the third, or negative 1 over 1,000 x to the third. But you can also do it this. This whole thing is to a negative 3. So I can just, because it's in parentheses, I can flip the whole thing down. 1 over negative 10 x. This is now a positive 3. So instead of raising everything to a negative 3 before and then flipping, I can just flip everything first, and then negative 10 to the third is negative 1,000 x to the third. Because this is nice and simplified. There's not a lot of extra exponents in here. It just depends upon the more experience you have with it, there's more ways to approach it. Okay? What you cannot do is look at another problem and go, I don't know how to approach this. I don't know what to do first. You do enough practice, you have lots of ways you can approach it, and you're confident with any one of them. But you only reach that level when you have enough practice. And I'm sorry for using so many, coaching analogies, but the reason why we practice in a sport is so no matter who we go up against, it doesn't matter. We're well practiced to handle anything we come across. Unless you're that, I'm going up against that kid back in my junior year of high school from Atwater, who our coach nicknamed Bubba McNasty. Because he was about 6'8", 320 pounds. I had, and then also, slow downs. John. Well, outside of Hanford, when I was coaching the girls, Chancelle's Pope. Hanford girls, they're starting a lot at 4-1 Division I colleges. This one. So if I use this approach, everything is going to get flipped down. It's now 1 over -10x, the whole thing to a positive 4. Everything flips because it's in parentheses. So it's now 1 over. That's a negative to an even, so it's going to be a positive. I don't have to worry about the sign. I know it's positive here. I knew it was going to be a negative. 10 to the 4th is a 1 with 4 zeros. So 1 over 10,000 and then times x to the 4th. 1 over 10,000 x to the 4th. -10 to the -4 times x to the -4. This has to be in parentheses, so you flip the whole thing. And don't forget that this is now going to be written down. 1 over -10 to a positive 4 times x to a positive 4. But when you do this, you got to make sure that negatives are the parentheses. Any clarification there? How about 7? What do you got on 7? Yeah. What's the rule when we divide? We multiply, we add the exponents. When we divide, we subtract. So that's rule 1, 2, 3. Rule 4 is a fraction to a power. The numerator and the denominator both get raised to the power. Rule 5 says when we divide a to the m over a to the n, as long as the bases are the same, you subtract the exponent. So this 5 to the 3x over 5 to the 2x is just 5 to the 3x minus 2x. That minus that. And 3x take away 2x is 1x. When we go over the quiz prep that I posted over the weekend, that one was more challenging. That one was more involved because it was a binomial. And this type of a question would be a bonus question on the quiz. Okay, there it is. And the same thing goes with number 8. I'm going to simplify the numerator and then I'll worry about the denominator. So I'm going to multiply this before I do this division in order from left to right. So this would be in the numerator 5 to the 48 happy face plus 3 happy face all over 5 to the 9 happy face. Happy face is just another variable. Don't know what happy face is. Don't care what happy face is. Never felt happy before. I hear something like, some people tend to experience, but I don't know what that means. But 48 of them plus 3 of them, that gives me 5 to the 51 of those happy faces. Because that's what you do when you multiply the same face. If this was a 2 happy face, or 2 to the third happy face, I can't add those happy faces together. Because the bases aren't the same. Cannot do it. Rule number 1, the bases have to be the same in order to add the exponent. So this is 5 to the 51 happy face over 5 to the 9 happy face. So now when we divide, we subtract the exponent. This is 5 to the 51 happy face minus 9 happy face. 51 minus 9 is 42. Happy face. All in those rules. A to the first, A to the 0 equals 1, provided A does not equal 0 to begin with. 1, 2, 3, 4, 5, 6, 7, and this is number 8. There's 10 rules, but we'll get to rule 10 when we get to chapter 2. I'll get to rule 9 and 10. Okay. So now what I'm going to do is I want to preview where we left off in class using the graphing calculator. Got some good questions, at least on the email. Again, it's very difficult to answer homework questions when they're just asked in the course of the email at some random time throughout the day. I mean, that's why I have office hours. You never know if I'm going to check it or not check it, so you're waiting for a response. And then if I get a chance to reply, do I know whether you understand my reply or not? And a lot of the times, those questions are basically right in the direction of the homework. Right here, 31 to 43, every other odd. Use a graphing utility. That would be a graphing calculator. This author always uses the word graphing utility. I don't know why for the last 25 years. Use graphing utility to graph the equation. Use a standard viewing window. Approximate any extra y interval. I did not get a chance to do this with you guys. We didn't go over this. But that was the question that somebody had emailed me with. I wasn't able to answer, or I answered it to the best of my ability, but it was kind of more difficult from coming from me because it's like I didn't cover this yet. This is for a lot of you very new because I have to explain what a standard viewing window means. And if you don't have the same calculator, I can't answer that in an email. Which button to push? Everybody's calculator can be different, so it's easier to demonstrate. What we did do was we stopped there. Which graph is it? We did the library parent function. So I'm just going to do this in 31. I'm going to do 32. So when we graph anything, you can only type in the right-hand side of an equation on a calculator. Y equals. The Y equals button on the 83s and 84s, and most every other calculator is, well, it's right here from 83 and 84. Where it is on the other ones, Casio, okay, Texas Instrument, sorry, not Texas, Hewlett Packards, all those weird ones, might be somewhere else. But I press the Y. And when that comes up, you cannot go, I mean, I can go left and right, but I can't type the equations over here. I can only type the equation to the right of Y equals. So when you get to number 41 or 43, you have to get Y by itself before you can actually type it in. That's something we'll be doing in class today. So I'm just going to type in 32, Y equals 2/3 X minus 1. Now, everybody's calculator is different. Mine does not have a nice representation for fractions, so I use parentheses. 2/3, 2 divided by 3. And then I close it. Otherwise, if I don't use parentheses correct, and I just type it in without, I just go 2 and then divide by and then 3x. Here's what I've run across before. They think I'm typing in Y equals 2/3x. Those of you who have a fraction that goes like this, Y equals, and you press the fraction or whatever, and it opens up a box that looks like this. So you type in the 2, and you're not paying attention, so you type in the 3, and you hit X. If you're not paying attention, it'll put the X down there because that's the next place it's going to type in. What you have to do is you have to use a little arrow keys and make sure you're out from underneath the denominator. So you can put the X next to it. It's 2/3 times X, because that's a different picture. The calculator is always going to be right. What you put in may not be, but it will always give you the correct answer for what you put in. So parentheses for me. I get paranoid. So parentheses 2 divided by 3, and then times now X. This right here. It has X and a T and a theta and an N. That's because there's different modes for graphing. The T is when we're graphing parametric equation. Theta is when we're graphing in polar form, and N is for graphing sequential equation. We're focusing on our Cartesian graphs, which is just X's and Y's. So instead of using alpha, which is alphabet, and then finding the X somewhere around here, where's the L's? There's the X in green. You just hit this, hit that, and you'll get an X. There, and there's the X. And then -1. And then you hit enter. Now, if I just graph, the graphing button is over here in the top right. That is not the right answer. Because the directions say use a standard viewing window. So standard viewing window means right here, zoom. All of these are your viewing windows. You can zoom in, zoom box, you draw a little box around it, we'll zoom in right in on that box. Zoom in, zoom out, zoom decimal, zoom square, and then right there, number 6 is zoom standard. These are set X and Y values, so it gives you a X and Y domain and range, the coordinates on the X and Y axis. So number 6, and you can either scroll down or you just hit the 6. Standard. And what it does is it changes this to a -10. That's a +10. This is a -10, and that's a +10. So it gives us that's the standard dealing window. From the x-axis, -10 to 10, y-axis, -10 to 10, and these little notches are 1 unit apart. So that's what happens every time you press zoom standard. It's going to give you these. -1, -2, all the way to -10, -1, all the way down to -10. So this is the equation of a line, y equals mx plus b. So b is -1, that's the y-intercept. It crosses right here at -1. And then the slope, which is something we're going to talk about in 1.2 today, is 2/3. Slope is rise over run. So the rise of the line from here, we go up to, so we go from here, we go up to, sorry, 2 over 3. We go up to 1, 2, and we go over 1, 2, 3, and that's the next point on the line. Up 2 over 3. And it's like a staircase, up 2, and then over 3. Up 2 over 3, up 2 over 3. And that gives you every point of the line. The y-intercept tells you where you can start, and the slope tells you how to find the next point. But all you have to do on these problems is put in this equation and then copy that picture on your homework. Just copy the picture. And I gave you, I printed the graph paper. I guess I must not have found it, unless maybe I didn't print it, but I printed them now. I have graph paper, I posted it, so when you print your own, everybody was going to get some graph paper. It's better than just drawing your own. All right, I'm on back to 10.